Hello and welcome to another video. So in this video we're going to see about GCD. So what is GCD? GCD stands for greatest common divisor. So in this problem we have given two numbers a and b and we have to find the greatest number which divides both of them. Okay, so let's first start with the brute force method here. So in brute force method, first we have to find the minimum of the two numbers, that is given numbers a and b, and we find it as k. Okay, and initialize g to 1. If this loop does not run, then the greatest common divisor will be 1. Okay, that is these are the co-prime numbers. Okay, now starting with the I is equal to 2, going to the smaller of the given numbers, we can find if this number divides both of them a and b, then we will initialize g to I. Okay, and by the end of the loop we will get the greatest number which divides both of them. Okay, that is the brute force method, and you can see it is the linear method and it takes o of the given k, that is the minimum of the given numbers. Okay, that is the complexity of this brute force method. Now there is another method that takes less time, and that is the mathematical method of Euclid. Okay, now this method gives us a rule that if we subtract the smaller number from the bigger number, that is the two given number here, we have the GCD of the initial two numbers and the current two numbers after subtracting are not different. Okay, now for example, if we say we have given 2 and 20. Okay, now if we subtract the 10 from 20, we get 10 and 10. Okay, now the GCD of these two number, that is 10, and GCD of these two number also 10. So GCD is not changing after subtracting. Okay, now this method says instead of dividing we will instead of subtracting we will divide. So in division method we will find the remainder until the remainder becomes 0. So division is nothing but the multiple subtraction. We will subtract the smaller from the bigger number until there is nothing to divide, that is remainder becomes 0. So in this method what we do, we will use recursion for this method. That is, let me do this. So in the base method we will assume that this a is smaller. Okay, we will assume this a is smaller. Even if it is not, it will become smaller in the next iteration. Let me show you. A is 0. If a is 0, we will return the b. Okay, if a is 0, we will return b. That is the base case of the recursion. Else we will return GCD b mod a and a. Okay, so what we are doing, we get the a and b. If a is 0, we will return b, unless we will return b mod a. Now whatever the condition is, if a is bigger or b is bigger, this will be smaller than both of them. Okay, so it will be smaller than a as short. So we will pass the a in the second variable argument, and we get the next iteration as b mod a, and we will continue the recursion continues until the a becomes 0, and we get our answer as GCD. Okay, so let's run to check. So we will get 10 and 20. We get 10. Okay, let's run it again. So let's say 35 and 28. We'll get 7. So yeah, this is working, GCD function. Now this algo takes o of log k. Okay, now the k is the smaller number between the two numbers. Okay, so this is the GCD algorithm using the Eculidean method. Okay, thank you for watching.